All right, tonight I just wanted to go over equations of a line in the few different forms that we're going to be looking at, so that Monday when we come into class we can look at equations of parallel and perpendicular. And I won't have to review this, we'll be good to go. So there are two very commonly used forms of equations of lines, the first being slope-intercept. So slope-intercept form is y equals mx plus b. So we've already discussed that m is the slope of the line, but b is the y-intercept. So the y-intercept, I just want to make sure that you understand what that word means exactly. That's where the line crosses the y-axis. So that's going to look like the point 0 something. For instance, 0, 3. If the point where the x is 0, that is your y-intercept. So this would be your b of that equation. It's where it crosses the y-axis. Okay? And then we have point slope form. Point slope form is y minus y1 equals m times x minus x1. Okay? Again, here, m is slope. And then x1, y1 is just a point on the line. So what I want to do is I want to practice graphing a few lines and writing the equations of a few lines with you guys so that you'll be good to go on Monday. So let's go ahead and look at this one. It says we want to write the equation of a line in slope-intercept form. So as soon as I see that, I'm going to stop and I'm going to recall what is slope-intercept form. And like we just talked about in the last slide, that's y equals mx plus b. So here we're told that the slope of this line is negative 1/2 and the y-intercept of this line is 8. So if I'm writing the equation of this line, all I need to do is plug in my slope and plug in my y-intercept. So this equation would be y equals my slope, which is negative 1/2 x, plus the y-intercept, which is 8. So this would be the equation of that line. Now let's work on graphing that line. So when you're graphing a line, and it's in slope-intercept form, the best way to do it is to first graph the y-intercept. After you graph the y-intercept, you're going to use the slope to get another point on that line, and then you just connect them. Cannot spell another. Okay, and so then I'm going to connect them using a ruler. Okay, it's not straight, it's not a line, unless you are using a ruler. Okay, so here my y-intercept is 8, so I'm going to go up on the y-axis 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. Here is my y-intercept, right at that little red point. Okay, and then my slope is negative 1/2. So my rise is negative 1, so I'm going to go down 1. My run is positive 2, and over 1, 2. That is another point on my line. Once you have 2 points, you can go ahead and connect those and have your line. So this would be the line with the equation y equals negative 1/2 plus x. Okay, so now let's look at this example. We want to write the equation in point slope form of the line with a slope of 4, and that contains the point -3, -6, and then graph it. So I'm going to recall point slope form is y minus y1, and that equals m times x minus x1. So it gave me my slope is 4, and my x1, y1 is -3, -6. So now I just need to plug everything in. So I'm going to have y minus -3 equals slope, which is 4, times x minus my x1, which is -3. Okay, and I made a mistake there. That y should have been -6. Okay? So now I'm just going to simplify and make sure that equation looks okay. So y minus a -6 is +6 equals 4 times x minus a -3 is +3. So the equation in point slope form of that line is y plus 6 equals 4 times x plus 3. So to graph a line when it is in point slope form, the first thing we need to do here is plot the point they give you. So I'm going to first plot the point. My point here is -3, -6. So I'm going to go over -3, up -1, or down -6. So 1, 2, 3, 4, 5, and 6. So that would be that point right there. Okay, and then my slope is 4. So I'm going to use my slope to get another point. Okay, so my slope is 4, which is the same as 4 over 1. So I'm going to go up 1, 2, 3, 4 over +1. And so now I can connect those 2 points with a line. And so that is the graph of a line that is at y plus 6 equals 4 times x plus 3. So that's just writing them in the different equations and graphing them. Let's look at writing one only given 2 points. So for this one, I want to write the equation of a line that goes through these 2 points in slope-intercept form. Okay? So if I'm going to put this in slope-intercept form, I first need to know the slope. So we need to find the slope of our given line. So if you remember, slope is y2 minus y1 over x2 minus x1. So I'm going to go ahead and just label my points really quickly, just so I can plug it straight in. So the slope of this line will be 10 minus 4 over 8 minus a -2, so plus 2. So 10 minus 4 is 6, 8 plus 2 is 10, so 6 over 10 simplifies to 3 over 5. So the slope of this line is 3 over 5. So now it says I want it in slope-intercept form. So what I can do here is I can plug it into point slope form and then solve for y. By solving for y, I will get it in slope-intercept form. Okay? So my first step is finding the slope. My second step is putting it in that point slope form. So you can pick either one of your points to do this. I'm just going to go ahead and use that first point, -2, 4. So by plugging it in, I get y minus 4 equals 3/5 x minus a -2, so plus 2. Okay, so now I'm just going to distribute. So y minus 4 equals, I'm going to distribute the 3/5 to each term. So that's 3/5 x plus 6 over 5. So now all I have to do is get that -4 on the other side of the equation. So I'm just going to write that equation back up here and show you how I would go about doing this. So what I would do is, since everything has a denominator of 5 on this side, I want to get 4 and a denominator of 5 as well. So if I bring it over here and look at 4, in terms of fifths, that would be 4 times 5 is 20 over 5. Do you agree that 20 divided by 5 is still 4? Yes, of course. So I can rewrite that as 20 over 5. So I'm going to do that. Y minus 20 over 5 equals 3/5 x plus 6 over 5. And so now I can add that 20 over 5 to each side. So y equals 3/5 x plus 26 over 5. And this would be my equation in slope-intercept form. So it's a little more involved. So the last thing I want to look at real quick is another one of these, writing the equation of a line in slope-intercept form. Okay? So again, I'm going to write out slope-intercept form. I need my slope, first of all. So if we're finding slope on this one, I'm going to do it a little bit quicker. I'm going to have 0 minus 0 over negative 1 minus 5. So that's 0 over negative 6, which is just 0. So this equation has a 0 slope. Okay? When an equation has a 0 slope, do you remember what that is? You should know from Friday that that is going to be a horizontal line. When you see a slope of 0, you should know that that line is going to be horizontal. But let's go ahead and get it into a slope-intercept form and see what happens. So if we put that into point slope, y minus y1 equals m times x minus x1, I'm going to plug in, I'm going to use my first point here. So that's y minus 0 equals 0, my slope, times x minus 5. So now I just need to solve for y. So y minus 0 equals 0 times x is 0. 0 times negative 5 is 0. So this becomes 0 minus 0. So y equals 0 is the equation of this line. So that's going to be a kind of hard one to graph. That's kind of a silly equation there. If I were to do that, though, I'm going to use this red line. The equation y equals 0 would just be this line here. Okay, it's that horizontal on the y-axis line. All right, so that's it for today. I know that this was really quick, but I just wanted to give you a brief intro into what we're going to be doing on Monday.